So uplift modeling basically combines our supervised modeling with A group, B group testing from more of that experimental design standpoint. So uplift modeling is going to allow for us to get away from our traditional experimental approaches and go more towards a customized approach for your customers. So think back to our first discussion from the beginning of the term when I started talking about Voter Vault and Dimzilla that were used as tools by the political parties to track voters and then use that data to customize their approaches for their voters as how they fit within their intended profile. And so basically that's what they were doing. So when we do uplift modeling, the first thing you're going to do is you're going to split your sample into control group and treatment group. You'll apply treatment to the treatment group and leave your control group alone or give it the same treatment that it normally gets. And then you're going to measure a change between the two groups. And then you're going to take that sample, combine it back together, and then randomly partition it into testing and training and validation sets. And then from there, you're going to develop a model from your training set with status change as your target and include a predictor variable indicating if the treatment was applied or not. And then you're going to run the model with your validation set with treatment set to 1 so that you can calculate the propensity. So basically P success per treatment equals 1. And then you're going to repeat it, but now you're going to set all the 1s to 0s. And so you can calculate the propensity of the opposite choice. And then you calculate your uplift by subtracting the two values. So let's look at an example of how that happens. So here we've got a table that shows a small extract of the actual data that was derived from a voter profile for Delaware. And so we have a campaign director that's going to conduct a survey of 10,000 voters to determine their inclination to vote Democratic. Okay. And so she conducted the experiment by randomly splitting the sample of 10,000 voters in half and sent the mailers to one half and then didn't send the mailers to the other half. And so this flyer or mailer that was sent out was, promoting a specific candidate. And so our control group is going to be the group that did not receive the promotional material. And the treatment group is the half that was sent the promotional material. And so the goal of the experiment was to measure the change in the choice after the message was sent out relative to the control group who didn't receive the flyer at all. And so we have our results summarized here on the screen. Basically, overall receiving a flyer was moderately effective. Movement in the democratic direction among those who did not get the message was 34.4%. And then the probability reflects the approach of the election. So think about the heightening campaign activity. And so because of all that, you're probably not going to have as many people that are in the no opinion category. And so this set right here actually kind of illustrates that need for the control group. And so if we look at those who did get the message, we see that the movement to Democratic was 40.2%. And so this resulted in a lift of 5.8% between the two. And so if we're saying like how much of a lift is our model going to be, basically what you do is you look at what happens if you don't give them a flyer or whatever your status quo is, and then look at what happens when you give them the treatment, and the difference between the two is going to be your lift. And so now we can take the data and we can augment it to reflect if the voter received a message and if they moved into the Democratic direction. So now we can develop a model with moved underscore AD as our outcome variable and the various predictor variables that we already have, including the treatment of if they received a message. So here's on the next slide, we're going to look at a few examples of on the first. All right, shoot. So the topic of this discussion is uplift modeling, which is basically when you combine supervised modeling with your traditional research A group, B group testing approach. So uplift modeling allows for us to get away from our traditional experimental approaches and go more towards a customized approach for your customers. So think back to our first discussion from the beginning of the term when I discussed voter vault and Demzilla as tools being used by the political parties to track voters. And they use that data to customize their approaches for the voters that fit their intended profile. And so they were basically implementing uplift modeling there. So if we think about the process for uplift modeling, first we take a sample and then we split that sample into treatment and control groups. And then we give a treatment to the treatment group, and then we measure the status change on both of them so that we can look at the difference between the two. We'll recombine the sample and randomly partition into training and validation sets. And then using the training set, we're going to develop a model. In this case, we're going to use status change as our target. And then you include a predictor variable that's going to indicate if the participant received a treatment or not. And then you run the model to the validation set with treatment set to 1, and then you're going to calculate the propensity. So that would be the propensity of the success of the treatment being 1. And then you're going to repeat the treatment and set everything to 0, and then calculate your propensity again, because what that's going to do is that's going to calculate the propensity of the opposite effect. And then the difference between those two is going to be your uplift. So here we have an example of a small extract of actual data derived from the voter vault or voter profile in Delaware. And so if we had a campaign director conducting a survey of 10,000 voters to determine if they were inclined to vote Democratic, what we would do is then we would take those 10,000 observations and we would split them in half. And half the observations would get some sort of message, promotional material, whatever, and the other half wouldn't. Okay. And so the control group is going to be the one that didn't receive the promotional material, and the treatment is the half that was sent the promotional materials. So here the goal of our experiment was to measure the change in their choices of option after the message was sent out relative to the control group who did not receive the flyer. And so here we see on the screen the results being summarized. And what we can tell is that the flyer was, moderately effective. We have movement in the Democratic direction among those who did not get the message was about 34.4%. And another thing we need to think about in here is if we're getting closer to the election, probably don't have that many people in the no opinion category. And so what we see here is this is really a good example as to why you need that control group so that you can compare the difference between your outcome variable without the treatment to what would happen with the treatment. Because if you notice here, without the message being sent, we had a 34.4% move to Democratic. And when they did receive a message or a message was sent to them, it moved up to 40.2%. And so we can calculate the uplift or the lift on that by just subtracting the two values. And so we have a lift of 5.8% just by applying the model itself. And so now that data table can now be augmented to reflect if the voter received a message as well as if they moved in the Democratic direction. So we're going to apply these same steps that we looked at before. We've already randomly split the data into treatment and control group, and now they were recombined, and then they were scored using the model. Now what we're going to look at is reverse the value of the treatment and rescore that same model. And so the reason why we're doing that is because we're going to be looking for the propensity of success given the opposite treatment. And then we'll look at calculating the uplift for the individuals. and then looking at a synthetic predictor here in a little bit. So here on the left is an example of the first few lines from the output of some of the predictive model used to predict if someone moved to Democratic. But remember, our interest here was not just how the message did overall, nor is it whether we can predict the probability that a voter's opinion will move in a favorable direction. Our goal is to predict how much the positive impact is from them receiving our message on a specific voter. And the purpose for that is so that the campaign can use a targeted approach with limited resources in order to promote the candidate by directing those resources towards the voters who are identified as those who are most likely to be persuaded. That's also why this is sometimes called a persuasion model, because you're looking at propensity to be persuaded. And so in order to evaluate the impact of the message on our voters, we're going to need to model the effect of the message on an individual voter level. So for each voter, uplift is defined as the increase in propensity of favorable opinion after receiving the message. So here we have some results of that reverse scoring that estimates the propensity of success given the opposite treatment. And so now that we have before the treatment, or we have it, the propensity of the treatment, and then we also have it for the opposite, now we can look at the two different predicted probabilities to calculate the uplift for the individual observation. And so here we would have those results for the uplift for each of the voters in the tables that we saw in the previous slide. Okay, so now that we've got the uplift, what can we do, right? So now you can sort these voters based on their uplift value and make a decision to only send the message to those with a predictive uplift value that are positive. If you have really limited resources, you might even want to do a cutoff score. And so it really kind of depends on what you want to do, but the idea is that you're going to sort them and make sure that you send your solicitation to the individuals that have the largest, most positive uplift values. And so we have two big purposes for uplift models. We once again determine whether or not we're going to send a message of persuasion to somebody, or also we can do these models to look at when the message is definitely going to be sent out to determine which message among the several is going to be most effective for my recipient.